This is Inchara from Sri Venkateshwara College of Engineering under the Department of Computer Science and Engineering in Cyber Security. Today I am here to give a brief information about Rook polynomials. Rook polynomials are a tool used in combinatorics to count the number of ways non-attacking rooks can be placed on a chessboard. They are used to solve various combinatorial problems such as counting the number of ways to place rooks on a board without attacking each other. Rook polynomials can also be used to solve problems in graph theory and other areas of mathematics. A rook polynomial for an n into n chessboard is a polynomial r of x that counts the number of ways non-attacking rooks can be placed on the board. The coefficient of x power k in the rook polynomial represents the number of ways to place k non-attacking rooks on the board. Rook polynomials can be calculated using reoccurrence relations of generating functions. Properties of Rook polynomials. Rook polynomials are symmetric, means r of x is equal to x power n into r of 1 by x. The leading coefficient of Rook polynomial is n factorial, where n is the size of the chessboard. The constant term of the Rook polynomial is always 0, as there are no ways to place 0 rooks on the board. Rook polynomials and chessboard tilings. Rook polynomials can be used to count the number of ways to tile a chessboard with domains. This problem is equivalent to finding the number of ways to place non-attacking rooks on the board. Rook polynomials provide a systematic way to approach and solve such tiling problems. Rook polynomials and chessboard symmetry. The symmetry of chessboard can impact the calculation and properties of rook polynomials. Different symmetries of the board can lead to variations in the rook polynomial and its coefficients. Understanding the relationship between the chessboard symmetry and rook polynomials is essential for analyzing combinatorial problems. Rook polynomials and integer sequences. Rook polynomials give rise to interesting integer sequences such as the coefficients of the polynomial. These sequences can be studied and analyzed to uncover patterns and relationships. Connections between rook polynomials and integer sequences provide insights into the underlying combinatorial structures. Let us look after the example. Find the rook polynomial of the following board. Here R1 is equal to 6 since 6 squares are in the board. C. Positions of two non-capturing rooks are 1, 4, 1, 5, 1, 6, 2, 5, 2, 6, 3, 5 and 3, 6. Consider the board shown in the below figure which contains 4 squares. For this board R1 is equal to 4. The number of ways in which two rooks can be placed on this board such that no two of them capture each other is 2. The two possible positions are 1, 4 and 2, 3. Thus R2 is equal to 2. These rooks cannot be placed on the board such that no two pawns capture each other. Thus R3 is equal to 0. Similarly, R4 is equal to 0. Accordingly, the rook polynomial for the board is R of c, x is equal to 1 plus R1 into R2 into x square is equal to 1 plus 4x plus 2x square. Applications of rook polynomials in graph theory. Rook polynomials can be used to solve problems related to graph coloring and independent sets. They can also be used to count the number of perfect matchings in bipartite graphs. Rook polynomials have applications in algorithms for solving combinatorial optimization problems. Limitations of Rook polynomials. Rook polynomials have limitations in solving certain combinatorial problems that are not directly related to Rook placements. They may not be most efficient tool for all types of combinatorial counting problems. In some cases, alternative methods or approaches may be more suitable for solving specific combinatorial challenges. A polynomial cannot have division by a variable, negative exponents, decimal exponents, and an infinite number of terms. Conclusion. The Rook polynomials are a powerful tool in combinatorics for counting non-attacking rooks placement on a chessboard. They have applications in graph theory, combinatorial optimization, and various other areas of mathematics. Understanding the properties and applications of Rook polynomials can lead to new insights and solutions in combinatorial problems. Thank you.